Alright guys, so we're starting chapter 4 here. Chapter 4 is going to be when we get into trigonometry, sine, cosine, tangent, the unit circle, all that good stuff. And really trigonometry, sine, cosine, tangent, all that is going to be the majority of what we're going to be doing this whole semester. So chapter 4 is going to be a really important foundation for us that you want to make sure that you understand really well. Before we get into trigonometry, we want to make sure that we start with angles. So angles just measure the amount of rotation. They've got an initial side and a terminal side. Terminal just means end. Now, normally when we draw angles, we draw them in the standard position, where they start on the right side of the x-axis. And then positive angles are actually going to rotate counterclockwise, and negative angles are going to rotate clockwise. If that seems strange that the positive is counterclockwise, you can think of it that positive angles rotate towards the positive y values, and negative angles rotate towards the negative y values. I'm going to sketch some angles here. And one of the things we want to look at is just what quadrant the terminal side where the angle ends up is. As you probably remember, we've got quadrant 1, 2, 3, and 4. So we're just going to roughly sketch the angles as long as they're in the right quadrant. That's good. Of course, our reference points, with our basic angles, we've got 90 degrees, 180 degrees is half a circle, 360 degrees is a full circle, and then 270 degrees is straight down. So if we've got 100 degrees standard position, we draw the initial side on the right side of the x-axis there. 100 is a little bit more than 90. So the angle is going to be something like that. Now when you draw an angle, you can't just draw the initial and the terminal side, because there's multiple ways that you could have rotated to end up at that terminal side. You could have rotated backwards, you could have gone in a few full circles. So we draw a little curvy arrow to show the actual rotation that we did to land at that terminal side. And so of course we're in quadrant 2 here. All right. So that one was a positive angle, so we rotated counterclockwise. This one's a negative angle, so we start at the same place. We still start on the right side of the x-axis, but now the negative means we're going to rotate the other way. And so we're going to go negative 90, negative 180, and then we don't quite reach to negative 270, so we're still going to land in quadrant 2 again here, just a little bit past negative 180. And again, we've got to draw the curvy arrow to show how we rotated. We didn't have a positive angle here, we had a negative angle rotating that direction. Okay. So then if we have negative 400 degrees, well, you can pretty quickly tell we're going to rotate more than a full circle here. So anytime that you rotate more than a full circle, you want to see how much more. So after we do negative 360 degrees, after we do that full circle, we need to know how much extra to rotate, how much is left, which of course will be another negative 40 degrees. So we're going to start at the same place, and then we're going to rotate backwards a full circle. And then after that, negative 40 is not too much more, so we're just going to be down here in quadrant 4, somewhere around here. And so again, we need this curvy arrow here to show us that we didn't just do a small little bit of rotation right there, we did a full circle and then a little bit extra. And then we're in quadrant 4 here. Okay, so 450 degrees, again, we've got more than a full circle, so separate that out. You're going to go 360 and then an extra 90 degrees. So you're going to start right here, you're going to do a full circle, then an extra 90 degrees is going to land you straight up right there. Okay. Now that one's not actually in a quadrant, it's between quadrants. We've got a special word for that, we call that quadrant. Anytime the angle lands on one of the axes between the quadrants, we call it quadrant. So that's degrees, that's one way of measuring angles. We've also got another system for measuring angles called radians. The thing about degrees here is this was pretty much arbitrary. Somebody just decided that a full circle was 360 degrees. It's just arbitrary. So we wanted another system for measuring angles that wasn't arbitrary. It was actually based on something. And so radians is based on the arc length. The idea is if you know how far you rotated, that's related to what distance you traveled around the outside of a circle here. That distance around the outside of the circle here, the part of the circle here is called the arc length, right? Well, of course, that distance is going to change based on how big the circle is. If you had a bigger circle, it could be a bigger arc length, even if it was the same angle. And so it's the relationship between the arc length and the radius we look at for radian angles. This is where radians come from. All right, and so we want to see the relationships between degrees and radians. So we know in degrees a full circle is 360. Let's try to figure out what it is in radians. Well, if we had a full circle, we wouldn't call it just the arc length anymore. If it's a full circle, the arc length would also be known as the circumference. So for arc length, we can say circumference. The formula for circumference is 2 pi r. And then the radius, let's call that as r. And so then those r's will cancel out, and we get 2 pi. So that means that 360 degrees, a full circle in radians, we're going to call it 2 pi. So that's one thing to keep straight. In radians, one full circle is actually 2 pi. That confuses some people sometimes. Right? And so then we can simplify that to a simpler relationship here. If we divide both sides by 2, we get that 180 degrees equals pi. And so that's the relationship that we can use to convert back and forth here. We know that pi and 180 degrees are equal to each other. And so if we multiply by pi over 180 or 180 over pi, we're really just multiplying by 1. And so that is something that we're allowed to do. We'll keep the angle equivalent, and it will switch it back and forth for us, like multiplying by 1 foot or 12 inches, or 3 feet over 1 yard. So we just need to know which fraction to use. So if we're starting at 60 degrees, the way I remember it is you want to cancel out what you started with. So I'm trying to cancel out degrees. So that means I want to put degrees in the denominator there. So I'm going to put 180 degrees in the denominator. So I've got pi up here. And so then we can just do some canceling right there. 60 over 180. 60 goes into 180 3 times. And those degrees cancel each other out. And so we've got pi over 3. So 60 degrees is pi over 3 radians. And that kind of makes sense if you visualize it. So 180 degrees is a straight angle. So if you look at 180 degrees there, that's pi. Pi and 180 are the same thing. And so 60 degrees is a third of that. So if you divided that into 3 pieces here, each piece is a third of 180, is a third of pi. So this 60 degrees is a third of pi. Divide 180 degrees into 3 pieces. And each piece will be that 60 degree rotation. Okay, so if we want to go the other way, if we're starting out with radians, well, now what we want to cancel out is the radians. And so we put the pi in the denominator there that cancel out the radians. We want to end up in degrees. We put degrees in the numerator. And so then those pi's cancel out. 2 will go into 180 90 times. And so then 3 times 90, we get 270 degrees. So 3 pi over 2 radians is equivalent to 270 degrees. And again, that should kind of make sense. If we look at 3 pi over 2, we're often going to look at radians as mixed numbers. So this is 1 1/2 pi's. So, well, 1 pi plus 1/2 a pi. We know that 1 pi is 180 degrees. Well, if 1 pi is 180, half of pi, half of 180, is 90 degrees. So 180 plus 90 degrees, that gives us the 270 degrees. So everything's matching. All right. Probably the most important thing from today is this last thing that we're going to do here. Not probably the most important thing, definitely the most important thing, sketching radian angles. You want to make sure that you're really, really good at sketching radian angles without converting them to degrees. We want you to get really familiar with radians. So when you first learned angles in geometry, it was probably all degrees. And then in Algebra 2, they taught you radians. And so it was probably more degrees than just a little bit of radians. In pre-cal, where we're going to keep the progression going, we're going to make it be mostly radians and just a little bit degrees, because then in calculus, it's all radians. You're never going to see degrees in at least in AP calculus. It's going to be all radians all the time, because since radians aren't arbitrary, they work a lot better for calculus. So please, when you're doing these sketching radian problems, do not convert the angles to degrees. You're just going to be handicapping yourself. You want to start to get really, really comfortable with radians. Okay? And so the way that we're going to sketch them is just like with degrees. We had kind of our anchor points here. We had 90, 180, 270, 360. We're just going to look at what those are in radians. So we know that full circle in radians is 2 pi. So again, keep that straight. One full circle is 2 pi. 1 pi is only half a circle. Right? Well, if pi is 180 right here, half of pi we just saw is 90 degrees straight up. And then we just saw 3 pi over 2 is 270 straight down. 1 pi plus another half a pi. And so we're going to use these as kind of our reference points to figure these out. One of the best ways is probably just to look at these as mixed numbers. So if you look at this as 1 3/5 pi, right? So we're going to start over here, and then we know we need to rotate more than 1 pi. So we're going to go past 1 pi. We know we're going less than 2 pi, so we're somewhere between 1 pi and 2 pi. So we know we're either in quadrant 3 or quadrant 4. And the question is, well, which one? Well, we know the dividing line is this 3 pi over 2, this 1.5 pi here. So the question is, are we less than 1.5 or more than 1.5? Well, if we look at this here, 3/5 is greater than 1/2. Half of 5 would be 2.5. So if 3/5 is greater than 1/2, and we know we're going to be a little bit past this 1.5 point right here. So our angle is going to be in quadrant 4, just a little bit past 1.5 pi. All right. Now, if we're going negative pi over 5, this is just negative 1/5 pi. Well, 1/5, that's a pretty small fraction. That's less than 1/2. So if we went negative, we'd have negative pi over 2, or negative half a pi. And we'd have negative 1 pi, and then this would be negative 1.5 pi's, and then back to negative 2 pi's there. But we haven't even done much of that at all. 1/5, that's not very much. That's a small fraction to rotate. And so we're just going to still be in quadrant 4 here, since 1/5 is less than 1/2. We haven't rotated past that straight down angle. We haven't rotated into quadrant 3 at all. All right. Now, 7 pi over 2, again, we'll look at this as a mixed number. This is 3.5 pi, right? So just like in degrees, we knew when we had kind of this bigger angle, we know, oh, hey, that's more than 360, so we're rotating more than a full circle. Same thing here. We need to look at this and say, hey, that's more than 2 pi, so that's more than a full circle. Just again, keep straight, the 1 full circle is the 2 pi. So right here, what we've got for 1 full circle, we take out the 2 pi, and then the extra is 1.5 pi. So it's not 3 full circles here, it's just 1 full circle, and then an extra 1.5 pi. So I'm going to start here, do a full circle for the 2 pi, and then we're going to go an extra 1.5 pi. So we're going to go an extra 1 pi is 180, 1 pi is straight to the left there, and then half a pi is like 90 degrees, that's straight down. Again, 3 pi over 2, 1.5 pi is straight down there. So after we did the full circle, we do this 1.5 pi straight down. So our angle of a full circle, and then straight down. We have that quadrantal angle. Okay. Now this last one might look a little bit funny. You might wonder where's the pi. Radians don't have to have a pi in them. If an angle doesn't have a degree symbol, then it's automatically in radians. Okay, and so what we have to do is we just have to look at these kind of anchor points as decimals instead of pi's. So we know that pi is about 3, so that means 2 pi is about 6. Well, pi over 2, 3 divided by 2, that's about 1.5. So then 1.5, if we add 3 and 1.5, 1.5, 1 plus a half, pi plus half a pi, we've got about 4.5. So if you're trying to sketch radian angles that don't have the pi on them, you just look at decimal approximations for these right here. So 2.1, that's between 1.5 and 3. So it's going to be somewhere here in quadrant 2. So again, this last section, this is by far the most important thing. You become really good at sketching radian angles without converting those to degrees.